we're going to go over some of the answers here. So number 6, free body diagram, you're going to ask to determine the net forces and if there's an acceleration, which I realize now we really didn't talk about acceleration, but acceleration is when there is an unbalanced force. So for the first one, if you look at the net forces here, you're going to find that it's 10 newtons to the left, and since there is an unbalanced force, there is an acceleration. Letter B, there is no net force, so there's no acceleration. And in letter C, the net force is 15 newtons, and it's up because this one is larger, and there is an acceleration. Number 7, during an in-class discussion, Analytical suggests to her lab partner that the dot diagram for the object in C6B could be what's shown here below. Anna's partner objects, arguing that the object in 6B could not have any horizontal motion if there are only vertical forces acting upon it. Who is right? Well, let's just take a look. 6B here is balanced forces, which means that the object is either at rest or moving in a straight line at a constant speed. So this dot diagram does kind of go along with that. And Anna is right because it could be moving in one direction or the other. But there's no acceleration, but there can be horizontal motion. So again, this is one of those tricky things. So just because we see this that has balanced forces doesn't mean the object is not moving. Number 8, during an in-class discussion, Erin again asserts that the object in 6A must be moving to the left since the only horizontal force acting upon it is a leftward force. Is he right? The answer is no. Seeing these forces does not tell us which direction the object is moving. So he incorrectly thinks that forces cause motion and that a leftward force is consistent with leftward motion, and this is not correct. The author here wrote, "This thinking causes Isaac Newton to roll over in his grave. The fact is that forces cause accelerations. The fact that the force is friction is an indicator that the object is probably moving to the right and slowing down, consisting with a leftward acceleration and a leftward net force." So all these details here at the end about friction, which we haven't talked about yet, is okay. You don't need to understand this. Later on, you will understand this and you'll look back on this. But just because we have a net force that's to the left does not tell us anything about the direction of motion. Again, this is a concept that most students walk into this class thinking, but it is incorrect. So number 9, the diagrams below depict the magnitude and direction of all the individual forces acting upon an object. Which objects could be moving to the right? Circle all that apply. The answer is all of them. So any of these objects could be moving to the right since a net force does not indicate which direction an object is moving. So to proceed, I am going to have you work on your MOP app, and you are working in part 2, not part 1, because Newton's laws of motion is in part 2. I'm going to come back to NL 1. So when you're in there, you're going to look at the assignment and you're going to find the one that says Newton's law, and it's going to be number 2. I'm going to come back to NL1 in the next section because there's things that we don't quite know yet enough. So do your best. If you can't get all the questions, send me an email with questions. There is a question bank incorporated into this, and your question might not be identical to your classmates. As well as if you miss a question, the next time you might see a similar question, but it might not be exactly the same, and you have to read carefully. So it's really important to not spend an overwhelming amount of time on these questions. If you get stuck, you're stuck. Email me, send me a question, okay? Here is one question that you're going to have something similar to this. It may not be identical to this, but it's we haven't talked a lot about acceleration other than this little bit on the back of the same worksheet. So the forces acting upon an object are balanced. Therefore, one can be absolutely certain that the object blank, and you're going to include all that apply. So can you guarantee that it's moving? Well, no, because when it's balanced, it could be stationary. B is moving and moving with a constant velocity. Again, it could be at rest. C, can you guarantee that it's at rest? Well, no, because it could be moving in a straight line and in a constant velocity. D is not moving, is not an acceptable answer. E is accelerating. No. F is not accelerating. Well, yes, you can guarantee that. And G is moving. So in this case, the correct answer is that it is not accelerating when it is balanced. And that is the only one of these you can be absolutely certain that is a fact about the object. So I want you to go ahead and work on NL2, do the best you can. Ultimately, if you finish and get all the questions correct, you're going to write down your MOP app code and send that to me. And so until next time.